So an introduction into what and this is normally degrees of Fahrenheit. Temperature measurements used to be useful and not biased by environmental temperatures, which is things like the being outside in the cold can make your skin cooler to the touch. So when if they use like infrared or something like that, or thermometer is reading, they could be influenced by that. So to get a reproducible and non-biased temperature, it's usually done through esophageal or rectal temperatures, and esophageal is considered the gold standard. The exposure to warm environments can lead to heat stress and heat stroke in workers. It's especially a concern for those who have encapsulated protective clothing because you don't want anything getting in, any chemicals or anything like that can affect their sweat or evaporative cooling you can get out, and so it's trapped inside as well. The specific workers they talk about in the introduction of this paper are firefighters and those like hazmat, thinking like level A suits or firefighters that have to have highly high temperatures and clothing. Rain can be a major problem. The core temperature continues to decrease, but the heat produced by the muscular work and environmental conditions can't dissipate through the clothing system. And the board is concerned about heat stress and heat stroke in workers that they tend to be moving around a lot. It's a very physical job, and the heat can't escape through the blood. And so right about it. The purpose of this study was to compare how well an invisible temperature telemetry sensor system, which is just the temperature pill, tracks rapid changes in core temperature compared with esophageal temperature during exercise in subjects wearing chemical protective clothing, which limited both their evaporative heat transfer and dry heat. The esophageal temperature, being the gold standard, it's hard to use in the field since you're connected to the sensor and it's down your throat or down your nose, and so it's not very comfortable or practical for firefighters or hazmat. So to give an overview of esophageal temperature, like I was talking about earlier, it's inserted through the mouth or the nose, and then it goes down the distal esophagus till the tip of the sensor is about 1 centimeter above the gastroesophageal junction. And this is typically done, or this is a common thing in anesthesia when patients are unconscious, to monitor temperature. And it's considered a somewhat obtrusive measure of core temperature. Like I said earlier, you're connected or you're tethered to the monitor, and it's not very comfortable to have a tube down over here. An overview of the industrial common sensor, which is the core temperature. So it's taken by mouth and takes about 2 hours to provide accurate core temperature, and all of your digestion tract and is excreted like anything else, and so after about 18 to 30 hours it will pass through the digestive tract. And because it exits the digestive system like everything else, it is one-time use. And this is a diagram of it. We have the temperature sensing crystal here. Then we have the communication coils that are, I believe it's FM signals that are being broadcast to a receiver that is basically keep track of the temperature. And like I said earlier, it has an outer silicone coating, so when you touch it, it's going to attack you. And it has a battery so that it has its own power source. For methods of this study, there were 4 study participants and 8 total experiments. They took or had each participant did the experiment 1 to 3 times. And all 4 study participants were. The average age was 25.6 years with a 1.6 deviation, which seemed large to me considering we only 4 study participants. The 2 methods were used to measure core temperature. When they arrived, the participants swallowed the telemetry pill with water and then were fed a light breakfast. And about 2 hours after taking the pill, the esophageal temperature probe was. And the esophageal temperature was it was a predetermined location to where it would be set. They use a thermistor, and basically started at about 25% of the height of the person in the esophagus, and inserted that until they hit a peak temperature, and they call that the hot spot, and that's where they had the esophageal sensor stay throughout. So after they had both the pill and the esophageal sensor in, participants dressed in their chemical protective clothing, and they specifically said that they were in their battle dress uniform, which is the camouflage combat uniform you see military individuals wearing. The overgarment, which is a fabric that goes between the legs and then is secured around like the waist or the hips. You have over boots, which go over the boots, and they're designed for military use in chemical and biological warfare. Then they put on hoods, gloves, and an open. The environment that they were exercising in was quite hot. It's 86 degrees Fahrenheit or 30 degrees Celsius. And they wanted to let them to adjust to the environment, so they gave them about 15 to 30 minutes in the environment before starting the exercise. Then the participants began and continued treadmill exercise for 60 minutes. From my examination of the study, all we get about treadmill exercise is walking. So there's no description of how fast or if there was a constant speed that the treadmill was on, or if there was a certain distance everyone walked. So all we really get is that they were walking for those 60 minutes. We don't know if there are any breaks or anything like that. The esophageal temperature and pill temperature were measured every 30 seconds, and heart rate was measured at 5-minute intervals by. And I was surprised by the fact that the heart rate measurements weren't, like, no statistical analysis was done with that. Basically, all they say in the results is that on average they were coming close to 170 beats per minute, but we don't know who that was, if that was an average of everybody or just one individual. So results, I don't work with Celsius like ever, and so in case anyone's in the same boat, this like really means nothing to me, so I changed it to Fahrenheit just to kind of orient us better, but I'm going to read it in Celsius since that's how the data is presented. But the resting esophageal temperature, so before they were exercising, was 37.11 degrees with a 0.21 degree deviation. And the resting pill temperature averaged is 37.17 degrees with a 0.27 degree standard deviation. And without any statistical analysis, you can see that these are pretty close. The difference in both of these is in the hundredths place. And then moving on to post-exercise, the esophageal temperature averaged 38.6 0.67 degrees with a 0.28 standard deviation. And the pill averaged 38.71 degrees with a 0.33 degree standard deviation. And we can see that these are similar, but the differences is bigger in the 10th place for both of these. A least squares regression was used to compare the two temperature measurements, having the esophageal temperature on the x-axis, the pill temperature on the y-axis. But those were our two variables. And of all the experiments run, the average correlation coefficient was 0.98. And typically about a 0.8 to a 1 is they're highly correlated. This is not all the results, just 2 of the 8 that I wanted to show. So this shows our esophageal temperature on our x-axis and our telemetry y-axis. And there's plotting when at 37 degrees, the esophageal temperature, what was the telemetry pill temperature. And this we had a correlation coefficient of 0.91, which is highly correlated. And this is really similar. It's just a different participant. These are our results. So this is the only table in the whole study, but we have our correlation coefficient here. We have our slope. So this is for every 1 unit change in esophageal temperature, how much the pill temperature changes. And then a 1 represents that they're changing at the same rate. So these ones are the pill temperature is behind a little bit, and these two is. Strengths, I like that they compared it to the gold standard. A lot of the studies I was looking at were comparing it to rectal temperature while still acknowledging that esophageal was gold standard. So I like that they used the gold standard. That I like that they individualized esophageal temperature pill placement. For each individual, they could have just chosen a set length and had it across the board the same. They used a commercially available. So I was actually trying to see how much they cost last night, and they, as of like the 2nd of this year, are no longer making them. So they were at the time commercially available, and anyone could really go and buy them if they wanted to use them in their workplace. And I like that they included exercise in the study design because the workers in the thermally resistant clothing are moving around while wearing it. And so I thought that was more representative than just having them sit there and seeing if the temperatures were the same. The weaknesses, they had a small sample size, only 4 people, and they were all women. Like we talked about earlier, the description of treadmill exercise is limited to walking. So there's a lot we don't know about that, about any breaks, if they were consistently walking, at what pace, if there was any incline. So I wish there was more explanation about what kind of exercise we were doing. It was a short duration, exercise duration for referencing populations working in highly thermal resistant clothing. They only sampled between 1 and 2 hours. And I believe that firefighters or hazmat workers often have to stay out longer than that, or be in their clothing for longer than that. I also thought that they had a really strong concluding statement that, to me, seems to be lacking statistical evidence. They said total change in pill temperature during the 60-minute experiment was not significantly different than the change in esophageal temperature, which to me is not significantly different. Means they would have had to run a statistical test on this, but I didn't find any evidence. Are there any questions before I go to my discussion questions? Or comments? Yeah, go ahead.
Nice presentation. What do you think caused the spikes in your data?
Yeah, they talked about that briefly, that the sensor lost connection. And that it only happened a few times, what they said, or it was infrequent, but are you talking about like the spikes that are different from the?
So in like the first figure, there's a few like giant spikes.
Yeah, that's what that is. So they said, or at least what they said was that the sensor lost connection.
Did they exclude that data in their?
Yeah,
I just think they study women.
I don't know, they seemed to, they called their study participants volunteers a lot, and they made a point to say that they were aware of the risks of what they were studying, and so I don't know if that's all they could get to volunteer or what, but do you have any thoughts about it?
Well, so we did studies looking at the University of Pennsylvania at strength, upper extremity strength, so shoulder strength especially, to model our assembly work. And if you're trying to protect 95% of the population, you won't study men. You want to get the women. The women have, men have about 2.5 times the strength in the shoulder, exact measurement. So in that kind of thing, you measure the women for that purpose. In other words, your whole thrust of what are you trying to do helps to answer that. I just don't know if maybe that's who was mainly in this population of workers that they're trying to model. But I didn't see anything. That's why I was kind of asking you to see what you thought about.
Right, yeah, I see what you said too. And then anything else before discussion questions?
More generic one.
Yeah.
Well, it's probably every student here should know. So what is a major variable? A wet bulb, low temperature, a major variable. I don't see it mentioned here. Should have been a major variable in here to make this reproducible. If you want to do the exact same experiment. Mention one.
Humidity?
Humidity.
Yeah.
It was probably higher than here, because it looks like it was in Massachusetts.
Yeah. So discussion question one, I kind of want to implement it into industrial hygiene, so I'm curious, what are some barriers to implementing the pill temperature tracking in industries that the city people do, so firefighting materials or hazardous materials spots? The few I came up with talking to firefighters was timing, that emergencies are not planned, so they would have to take this pill at the beginning of their shift. Or before their shift even started, so that we could there could be accurate data, and they might not even have a fire that day. And then the cost, they're roughly $40 per pill, and they are one-time use. And so if you're supplying a whole department with these every single day, it's gonna get really expensive. But does anyone else have any thoughts on implementing? Yeah.
They could utilize that when they're doing trainings, because then they know they're gonna be in that situation when they're doing the hot box or doing the building. That would be a better way to collect that data.
Go ahead, yeah.
Another barrier to it is people's willingness to trust, another pill and one that's gonna like communicate to outside my body. I mean, just thinking about the firefighter culture and that sort of thing, they're usually pretty open to new technology about new gloves or new equipment. But when it comes to what they put in their body and ingest and that sort of thing, they're gonna be generally more conservative than I think most.
Yeah.
Guessing, so, yeah, there's gonna be some cultural and personal factors that are gonna keep people from being willing to do this. I think what Rosie said about using it for training purposes, you know, both in terms of cost and also in terms of people being willing to do it, I think is gonna be much more effective than if you try and convince the old timers to do it. So that's my guess.
The young rookies would.
Yeah, rookies will do it. That's right, because they want the job.
I maybe have kind of a generic question that may or may not be related to
Oh,
this.
okay, yeah.
In what context do you see this being maybe a useful tool to apply? Because like you can collect training data with it, but then what do you do with the data, right? Like, are you collecting data just for the sake of having data? Or are you doing analysis with it or doing reports, or are there safety analyses that could be related to the data collected from using this pill? Or is it maybe not even a tool that's useful implementing outside of a research lab?
Yeah, that's true. From talking to firefighters, what I think it would be most useful for is that, really firefighters are just told the signs of heat exhaustion and heat stress, and they say, okay, if you have any of them, like, you gotta come tell me. But with the culture there, it's like kind of buckle down and get it done. And so I have a, family member who had 5 people that they worked with go down in 15 minutes from heat stress because they just were refusing to go and talk about it. So I think that whoever is medically or someone needs to be in charge of monitoring those ones, and then they take them out of the field when they hit a temperature that's no longer safe to work at. Does that answer your question?
Yes,
And
thank you.
sorry, Jake.
Well, I was the same as Dr. Allen, it's just, I think a big barrier is willingness to ingest something that,
Yeah, you guys are ahead of me.
Related to that, sorry, related to
Yeah.
that, I was thinking about, did I read correctly? This is from 1997?
Yeah,
Technology's changed a little bit since then, right? They were sold on a pill. Right now, you can get tactical gear that tracks temperature and so forth. In fact, they do that particularly for firefighters when they're responding to, you know, fires. They want to know what the ambient temperature in the environment is, because they can associate, they know how long a person can be in that environment before their body core temperature exceeds a certain amount. And they have other sensors that they're starting to use now and just in general that are not ingestible, but they're like, you put a node on their chest and then they're underneath all their gear. And when that node reaches a certain temperature, you know that their core body temperature has also exceeded a certain level. So we've seen a lot of development since this came out, which might make the pill process no longer really necessary because we can do it with things that are not ingested.
right, so even though it's on outside of the body and not necessarily measure core temperature, we have safety factors that
Yeah.
you're saying that they can then say, well, like we're pulling you out 3 degrees before.
Yeah, so
This
yeah.
is your, okay, yeah.
Yep.
That makes sense.
some do. I mean, these are the career fire departments that have money.
Yeah.
And hopefully a city that's very supportive, like Phoenix is gonna be an example that has some of this. Whereas volunteer fire departments, you know, where it's the farmer down the way who hops in his truck and goes and puts on some old gear from the 1970s and hops on the rig and drives it over to somebody's barn that's burning down. They're not gonna have anything remotely close to this, right? Obviously, so.
One thing I saw when researching this is really popular with athletes.
Yeah.
Because they know when they're gonna be working out and they can track their temperature that way, especially if they're working or outside and they're in their padding and stuff like that. And typically I think that cost to be a big barrier since it's typically publicly funded. Would use it or for the vocations that they identified in this study. So like you guys said, I anticipate workers if you're interested to adjust temperature checking technology. I think especially if it needs to be taken outside of working schedule hours because there's a delay in the accuracy of the reading. And so to like convince a firefighter to wake up 2 hours before the shift and take a pill, I don't know. That would really go down well.
I've got 2 online comments. We have two comments from folks online.
Yeah.
Michael McBain says in the operating room, we would sometimes use a stick-on forehead temperature strip, which is interesting. And then Micah comments that producing this data in a training setting would help a lot with supporting fitness standards that will help firefighters prepare for risk of heat stroke and also support policy like mandatory rest and cooling cycles when ambient temperatures at an incident pass a threshold. And then Mike followed up and said he doesn't have data on how accurate the forehead strips are, but it could be argued that their reading is more relevant than measuring other body sites. So.
And I did want to shout out Mike because he's one of the people I reached out to ask about firefighters and their culture and what is implemented and not today. So thanks, Mike. So, oh yeah, go please.
I just wanted to echo what Dr. Allen said, is that this predates even an iPhone.
Yeah.
So when you're talking about technology, we probably ought, as a group, probably ought to look forward and see was there anything more recent that would be relevant to today's audience. I know this is kind of like what, the research was built upon, but what's happening now, and thanks for Dr. Allen to sort of add that to the discussion, but
Yeah, for sure. This is something that we were introduced to last semester in our industrial hygiene class, so it's still, according to our professor, is still used. Which is I thought.
No, it's good. It's good choice.
No,
Yeah.
but still, that is a valuable and true statement.
Just piling on that I don't know if to what extent they've been validated, but in some environments where you have extreme external heat sources, I'm a little concerned about the sensors on the skin from the accuracy.
Yeah.
It really have to validate it. And you may even have to, depending on your what's going on site, if you don't have the studies, you have to even think about whether you do such a comparative thing because otherwise you can, significantly inappropriate guidance on what to do.
I'll just pile on. So we actually did a study at the smelter several years back where we were looking at that exact issue of actually using a thermal gun to measure different points on the face to see how well that actually relates to internal temperature measured using one of these ingestible probes. And some places on the face work better than others, but that external heat source made it really difficult. And when you're dealing with fire service, right, there's a possibility of meaningful external heat sources, but also a lot of exertion where you're generating your own heat in your body. So there's differences there too, that you can't just have, and maybe it's not just having one probe to say, oh, this covers everything, if heat stress really is your primary concern.
Fun stuff.
Thank you.
Good job.
They have a little machine that they have. Because I would think that. I think what firefighters do, correct. That means they have to, yeah, they have to return them to get the data, so.
Well,
I don't know, but.
I'm pretty sure they were.
The other side of the family, so. So say if you want to think about it, like, 24 hours.
Uh-huh.
Yeah, it has to be.
Like, turn on my sleeve.
I have a little plastic cubby.
Yeah.
It's back in clinic all the time. It's just one time testing.
Yeah.
Okay, I'm Taylor Cisneros, and I will be presenting on the comparison of measurement methods for benzene and polyethylene. So just a quick background to familiarize people with some sampling devices. So there's 3 different sampling devices used in this study, and the first one was an automatic BTX instrument. And I included a picture over there. It's kind of a big, bulky box in a sense. And so this is a combined sampling and analytical system. So we'll take your sample and analyze it right there on the spot, which is super nice. So air will get pumped in through a cold trap containing a sorbent that will trap the VOCs like benzene and toluene. And then the VOCs are then transferred by helium gas to a gas chromatograph with a flame ionization detector. And so what that is, that's the analyzer system. And so the GC will separate chemical components of a sample mixture to determine their presence. And then after that separation, each analyte passes through a flame fueled by hydrogen and zero air, which anions, wow, I'm so sorry. Anions carbon atoms. Once the ions are collected and measured, they create a current at the detector's electrode. So that's just kind of a brief overview of how it analyzes, but it's also like way more complex than that. That's just super simple. And so the other two devices that were used, they did a passive and / diffusive sampling. Those are used interchangeably in the study. And so that is, they're going to use one of these tubes. It did not specify if it was a stainless steel tube, like the bottom picture, or a glass tube. So there's just two examples of which one it could have been. But they will work the same. So you break the ends off of these tubes, and then air will just flow through the tube. And the little sorbent in the middle, these different sorbents, either a 10xTA or a carbopac B. This will just trap the VOCs. And they also used active sampling, so this will get hooked up to a pump which will pull air in, and that is what will trap the sorbent, the VOCs on the sorbent. And they use the same sorbents, 10xTA and carbopac B. So some background on the study. So there's actually been quite a few studies that have compared different sampling methods, but only a few studies before this time had compared diffusive samplers that contain the 10xTA and the BTX instrument. And so then another study showed pretty good agreement between the 10xTA and the BTX within 30%. So this study was just kind of confirming these and seeing if those were still true. And then another study showed that there was even better agreement between the BTX instrument and active sampling. So that was the pump and the sorbent tubes compared to the passive sampling. And so then the objective of this study was to quantify the accuracy and the agreement between passive and active sampling on the sorbent 10xTA and an automatic BTX instrument. So methods, so they did the 3 different sampling methods. They used the BTX, then they also did the passive sampling and the diffusive sampling, each with 10xTA and carbopac B. So they exposed the cartridges for various periods of time. They did it for 3 days, 4 days, 7 days, and 10 days. And those were done in the months of September and December. And they did it over the course of 3 years. They sampled in 1999, 2000, and 2001. So this is kind of like an older study. And they did this to show the changes in uptake rates and how that varies over the course of 3 days, what the uptake rates were over 4 days, 7 days, and 10 days on these sorbent tubes. And so for active sampling, an automatic carousel changed the cartridge every 10 hours. So those samples were changed out every 12 hours and a new sample was put in. But it did not specify any change out for diffusive sampling, which I thought was interesting. But yeah, samples were collected at street level. What I mean street level can be like on the streets, but about 3 meters off the ground for breathing zone references. And then at roof level in the city center of Stockholm, Sweden. And they listed the cities, but I don't know how to pronounce them. So but yeah. And so then active sampling for carbopac B was only performed at street level, but passive sampling for carbopac B was performed both at street level and at roof level. And then 10x was both street and roof level for both of them. And it did not specify why that was, which was also interesting. And then analyses were conducted at 2 different laboratories. They had the passive samples analyzed at one lab and the diffusive samples analyzed at another lab. And it also did not specify their choices behind that. So then going into the results, so there's a bunch of results for this as you're comparing 3 different methods using different techniques for each one. So this first result is showing active sampling versus the BTX instrument. And this graph right here is benzene, and that one is toluene. And we can see that they have pretty high R-square values. So it's pretty good in a sense. And they found that the correlations for both benzene and toluene were high, which is great. So it's saying that the results from the BTX are pretty similar to the results that they received from the active 10xTA samplings. And then this one is compared to the 10xTA and the carbopac-B for active sampling, so again, using that pump one. And there's also a high correlation was found between the concentrations measured using the two sorbents. And there's no significant difference between the two sorbents, so they came out pretty equal for both results. As we can see, they have really high correlation values as well. So again, the results came out really similar, which is a great sign. And then more results. So this one is showing diffusive sampling with 10xTA benzene and the BTX instrument. And so this one, they found that there's higher benzene levels obtained when using diffusive sampling than BTX instrument. So these results were not very cohesive in a sense. It said in the study that the 10xTA sampling showed about 30% higher values of benzene than the BTX. And this could be explained by, it said, a dose-dependent uptake rate with higher uptake rates at lower doses. And this goes, this correlates with a previous study that also showed a dose-dependent uptake rate, that there's higher uptake rates at lower doses for benzene. So this was, so this correlated with a different study, but the two results between the diffusive sampling and the BTX did not correlate with each other. And then, but after they did a correction, it didn't say exactly what this correction was that they applied. But then after the correction, the relationship between the uptake rate and dose, the two methods agreed fairly well. This one just needs some correction factors, but it did not specify what that was. So I don't know what they did for that correction. Then this one is the diffusive sampling with 10xTA toluene and the BTX instrument, and this one did not show a dose-dependent uptake rate. So this one, the results came out more in an agreement than with the benzene one. This one is comparison between carbopac-B versus 10xTA. And this was using diffusive sampling, and this one's primarily just for benzene. And it shows the different locations in the two cities, I'm not going to try and say, in the different months. And we can see for each location in a different month, that's the correlation between the two sorbents for passive sampling was high. For benzene, it said that the correlation was 0.89, and then for toluene, it did not show the graph, but the toluene correlation was 0.98, which is also super high. So the methods were not shown to be significantly different. 10xTA is found to be equal to carbopac-B for measuring benzene and toluene, but it is not. The 10xTA is not optimal for benzene, what the study stated. So then just some other random results that did not have any tables. So the 10xT for benzene, when they combined the 4-day samples with the 3-day samples, those samples together had higher concentration amounts than the 7-day sample. That was just a continuous longer sample period than the two shorter samples combined. And they found that there was a 7% higher in September and 40% higher in December. And then they also found that for using carbopac-B benzene, it was the same thing. The 4-day plus the 3-day samples had higher concentration amounts than the 7-day samples at roof level, but they were equal at street level. And then they also did the same when they compared the 10-day sample to like the 7-day plus 3-day sample. So these shorter periods had higher concentrations than the longer period. And then the 10xTA toluene showed 10 to 20% more toluene for shorter sampling periods compared to longer periods, but only in December. And then carbopac-B toluene showed no difference regarding length of the collection period at roof level and street level. And then uptake rates for 10xT benzene increased rapidly when going from higher to lower exposure doses. And then some conclusions that this study made is that since uptake rates should be constant for passive sampling, carbopac B should be used for benzene rather than 10-XTA. Because then when the 10-XTA was used, the uptake rates were not constant, they were fluctuating, which can alter sample results. And then further studies at low concentration using carbopac B should be conducted. And this is just to confirm that it is constant at these lower concentrations for carbopac B rather than 10-XTA. Then they found good agreement between active sampling and the BTX, both for 10-XTA and the carbopac B. And then toluene had better agreement between both methods, diffusive sampling and passive sampling than the benzene did. And I also went to several sites that sell these cartridges. And each sampling guide also did not recommend using 10-XTA for benzene, and it listed a whole bunch of other ones you could use instead. So the study is still continuing to prove true today to not use the 10-XTA. So some strengths and limitations I noted with the study. So some strengths was it used previous studies and built upon them. So it gave more like concrete background that this is a true thing that we can still rely on today, not use a 10-XTA, and it can be replicated pretty easily. It's all you really need is your sorbent tubes, pumps, go set them up and you're good. And then I also like how it looked at various factors, how it compared to at street level, how it performed there rather than roof level, and then how it did different sampling days, and then how it did September and December. So looked at it from different angles, which I thought was good for sampling, because like we just noted with Selah, like humidity can affect your sampling temperature. And then some limitations, the samples are not changed out equally. So they changed out the active samples every 12 hours, but they did not note that for diffusive samples, which if you're comparing samples, it should be about equal sample length. So unless they did, they just didn't mention it. I thought that was a limitation that they did not do that for comparison reasons. And then also that not all methods were conducted at the same sites, how they did not have the, I think it was the passive active samples for carbopac B were not conducted at both locations, whereas 10X was, and then it compared them. So also for comparison reasons, I thought that was a limitation. Okay, and then just some discussion questions I have, but feel free to ask any other questions, is why might this research be beneficial for sampling strategies if there was something we already knew? Personally, I think it's because sometimes we think that over time they'll alter these sorbents and stuff because technology is always changing. But this study further shows that no, you can't just pick any sorbent you want and expect it to react the same for toluene as it does for benzene. That's my opinion on that one. I don't know if anyone has any other thoughts.
Kind of related to this, what would you say is the main outcome or contribution of this paper? Like, is it the fact that they shouldn't use this certain exact method for benzene, or is it kind of a combination of like these street level versus roof level concentrations, or maybe something else?
Yeah, from what I gathered from this is that, so with sampling, there's like so many filters out there. Like if you go to a sampling guide or stuff, there's literally so many, and it can be hard to know which ones to use. And some people like use them interchangeably, especially when it comes to like benzene, toluene, xylene. And so I think the study did a really good job at showing, no, you can't just use these sorbent tubes, like they will react differently for these different chemicals. And so I think that was a big bonus with that, is just showing that some are more accurate and you will get more accurate responses for different sorbent tubes.
Thank you.
Yeah. Dr. Allen, yes. Something?
Well, I was just gonna say that, what's the interesting thing about this is that there are different ways to measure things,
Mhm.
right? Doesn't matter if you're talking about air or you're talking about the psychological conditions of people, there are different ways of measuring things. And you can't just assume that they're interchangeable, right? And I think that to me was kind of the message to me, is that, okay, when you're selecting the measures you're going to use for whatever study you're doing, you need to know what the parameters, the specificity and sensitivity and all the other psychometric, if you want to call them psychometric factors, but all the factors associated with that measurement. So that way you know whether or not you can put it in the place you want to put it, or have it measured the way that, use that measure, what the implications of that are, right? And so I think that's something that I think we sometimes don't think about as much as we need to when, designing and implementing a project, right? We can't just assume, oh, well, these worked over here, so they'll work over here too. Well, will they? Maybe, maybe not. Or this measure worked for the, under this circumstance, will it work in this circumstance? And again, we need studies like this to show us whether they do or not, but most validated measures have been used many times, and we need to do a little bit of homework to make sure that we're using it the right way. Yeah, so anyway, that's.
I agree with that, and kind of going off of that, it like references how the EPA method says not to use 10XT, and this was sponsored by the EPA too, so it's kind of boosting their cause for that in a sense.
Yeah.
So, but, yeah.
Yep.
And then another question I have is, what changes would you like to see for the next researchers on this project? But personally, there's stuff I found in this article that was left out that I would have liked to see. Like why they didn't change out the diffusive samples, why they didn't sample at street level for both of them. Or like it didn't specify even what type of sorbent tube they used, because that stainless steel one or the glass one. So some parts I found vague in this article, which in order to be really replicable, it would need to be more specific, I believe. But I don't know if any of you guys have any thoughts on that or just any other questions in general.